My name is Discord. I will not be doing binomial distributions. There are many probabilities experiments for which the result of each child can be reduced to two outcomes: success and failure. For instance, when a basketball player attempts a free throw, he either makes the basket or does not. Probability experiments such as these are called binomial experiments, such as shown below above. A probability experiment that satisfies the following is a binomial experiment. First, the experiment must be repeated for a fixed number of trials. These trials must be independent of each other. Second, there are only two possible outcomes: success and failure. Third, probability of success is the same for each trial. And fourth, the random variable x counts for each trial of success, for each successful trial. There's notations that need to be taken, such as n equaling the number of repeated trials, p being the probability of success in a single trial, q being the probability of failure in a single trial, represented by q equals 1 minus p, and then x being the random variable which counts for the number of success in each n trial. The formula is the exact x successes in a trial, p of x equaling n combination x, p to the x, q to the n minus x, n combination x being n factorial n minus x factorial x factorial. The example of this will be a microfracture knee surgery has a 75% chance of success on patients with degenerative knees. The surgery is performed on 5 patients. Find the probability of surgery being successful on exactly 2 patients. Using the binomial probability formula, the values of n, p, q, and x are 5.75 for success, 0.25 for failure, and x be the trials performed. In this case, the probability of x equaling to 2 will be done by the formula p of x n cx p to the x q to the n minus x, which then will be probability of 2, 5 combination 2, 0.75 to the second, 0.25, 5 minus 2 equaling 3. This would be probability of 2, 5 factorial, 5 minus 2 factorial, 2 factorial, 75 to the second, 0.25 to the third, This would then be seen as 5 times 4 times 3 factorial over 3 factorial with 2 factorial. 3 factorials cancel out, leaving to 20 over 2 factorial equaling to 10 times 0.75 to the second, 0.25 to the third, equaling probability of 2 successful surgeries being 0, 8, 7, 8, 9, 0, 6, 2, 5. B will be the probability of x being less than 2. This will be probability of 0, 5 combination 0, 0.75 to the 0, 0.25 to the fifth, probability of 0, 5 factorial, 5 minus 0, 0 factorial, 0.75 to the 0.25 to the fifth. This will cancel out as 5 factorial over 5 factorial cancel each other out into 1.75 to the 0.25 to the fifth, equaling probability of 0, equaling 0.009765563. Probability of 1, equaling 5 combination 1, 0.75 to the first, 0.25 to the fourth, 5 factorial over 5 minus 1 factorial 1 factorial, 0.75 to the first, 0.25 to the fourth, equaling 5 over 1, 0.75 to the first, 0.25 to the fourth, equaling probability of 1, 0.0146484338. Having this will be adding the probability of 0 plus 1 plus 2 equaling 0.103515.626. Then we will have in the third, in C, the probability of having x greater than or equal to 2, in which we will use the probability of 2, which will equal 0.087890625. The probability of 3, which would be 5 factorial over 5 minus 3 factorial 3 factorial, 0.75 to the third, 0.25 to the second, over 20 over 2 factorial, equaling 10.75 to the third, 0.25 to the second, equaling the probability of 3 being 0.263671875. The probability of 4 would then be 5 factorial over 5 minus 4 factorial 4 factorial equaling times 0.75 to the fourth, 0.25 to the first, equaling 5 over 1 factorial, 0.75 4 to the 4, 0.25 to the 0 to the 1, equaling the probability of 4 being 0.395507.813. Then we'll have the probability of 5 successful trials equaling 5 factorial over 5 minus 5 factorial 5, 0.75 to the fifth, 0.25 to the 0. Having 5 factorial over 5 factorial crossing them out equal 1, 0.75 to the fifth, 0.25 to the 0, equaling the probability of 5 being 0.237304.688. then they will equal the probability of 2 plus 3 plus 4 plus 5 equal 0.984375001, and this will be the end of binomial distribution.